Okay, I think we're live now. Okay. So, welcome everyone to the Exam 2 study session. This is going to be a review to help you prepare for Exam 2 in this class. I'm going to preface this. I'm going to preface this by saying that I know there will just be I'm pretty certain there's just going to be a traditional Canvas exam. There isn't going to be any GNS work. With that being said, unlike last time, I don't know what exactly is going to be on the test, nor do I know how many questions Dr. Assad is going to add. Um, when I redesigned this course during the summer before Dr. Assad took this class over, I created a bunch of quizzes and tests. He's been creating his own, which I'm perfectly fine with that. I'm actually really glad he's putting a lot of work into this class. I would say that I did highly recommend that he use my exam questions for this exam. I will see if he does. We'll see if he does that, but I'm going to cover most of what you've been learning, what is most likely to appear in the test according to the questions I made, and a few extra details. So I would say in general, it may be a safe and a good idea to go back to the previous modules, from the subnetting modules to the one in VLSM, to go back and review those PowerPoints just to make sure you understand all that stuff. But I would say the exam for the most part is going to cover sub solving for subnet IDs and broadcast addresses. Should also include some VLSM work. There's going to be questions on router-specific CLI commands and route types. We have a table for the latter part. And then finally, some basic information about routing protocols, mostly OSPF-centric, and then facts about OSPF and how to configure it. I should say most questions should be multiple choice, should be very similar to the last exam. I'm correct, that was multiple choice. If there are subnetting questions, there's a good chance they're going to be fill in the blank though. So you'll need to solve for those. There won't be calculators allowed. It'll probably be lockdown again, and I have a good feeling though that Dr. Assad should let you use scrap paper, because most of us use paper to solve for these when we don't have a calculator. So I would ask him that question, and I'll be sure to ask it too. But one way or two ways I recommend that you prepare for this exam is to use the study guide as a review of the topics you'll be tested on. And then if you don't feel comfortable with a specific topic, like subnetting, for example, you should go back to those PowerPoints and technical chapters specifically concerning subnetting. I cannot stress enough that you should take advantage of these no credit practice quizzes for subnetting practice. They are labeled like this. They have in caps no or credit practice, and then they have like CIDR conversions. They have calculating subnet addresses, which is the same thing as a subnet ID, by the way. There's calculating broadcast addresses, and finally calculating subnet mask, which basically converting from CIDR mask to decimal notation. These quizzes are located in chapter or module 5, and this is how I did well in the course when I was taking it. This is an immensely important component in this class. There's other ways to practice subnetting, but this is here in Canvas is very convenient. I would say take advantage of this because it won't cost you any points, and it's a way to practice over and over again the concepts of subnetting. I will say that I practiced the subnet address or subnet ID no credit practice quiz over 100 times when I took this class. Seriously. I took it every week, and I know you probably all don't have a ton of time before the exam, but I'd say really stress practicing this over the weekend if you got time, because this will really come in handy when you take the exam. Speaking of subnetting, we're going to go over a lot of the subnetting processes. So basically, I will discuss the subnetting process for subnet IDs and broadcast addresses. I'm going to go over the steps, and then I'm going to provide an enactment of them. I'm going to provide a practical example of them. So it'll help you better understand how to do it. The same is true for broadcast addresses. I've included some other topics, including converting CIDR masks, wildcard mask versions, and then also VLSM stuff. And then finally, we have these questions where you're given an IP address and the required number of subnets and hosts for a network. Then you have to find a mask that either maximizes the number of subnets in the network or the number of hosts. I don't know how much practice you all have had. I don't even know if it's going to be on the exam. It may not. But just in case, I would say practice these two. And let's see here. This quiz right here, calculating masks, that correlates to those questions. So it may be something you might want to practice just in case. It could very well be on the exam. So we'll go over that. So you can come back to this video and you can practice these quizzes, and you can use the steps I provided in the PowerPoint here to help you figure out how to do all these things. So with a little practice, you should be good. But let's go. For those who are having trouble still with subnetting, I'm going to go over each of these. Now, if you all have any questions, please enter in the chat. If you're confused on something at any point, let me know, and I'll stop and I'll explain it. So, to find a subnet ID based on a given IP address and CIDR mask, there are 4 major steps, technically 5. I divided it into 5 for this PowerPoint because you do need to convert the CIDR mask to the dot decimal notation, unless you memorize this. But anyway, it's good to figure it out on paper. So the first step is to examine the CIDR mask you're given, such as /25, and convert it to dot decimal notation. So /25, I've already figured it out for you. It's 255.255.255.128. Here's a hint for figuring out this calculation. The number of 255s in the subnet mask, or the dot decimal notation of the subnet mask, can be determined by dividing the CIDR mask number by 8. So 25 divided by 8 is 3. So therefore, there's going to be 3 255s. So memorization can be used to remember the non-255 and non-zero numbers in the octet, or non-zero number in the octet. So in other words, that's going to be our interesting octet for when we're solving for the subnet ID. So this number basically starts with 128 at the first classless mask. So what do I mean by classless mask? So there are 3 subnet masks that are classful. In other words, they're going to only consist of 255s and zeros. So that is /8, /16, and /24. Note that they're all multiples of 8. In between those, there's going to be, let's see, we look at this table here. So in between each classful mask, there's going to be 7 of these classless masks, and they're each going to start with a specific number. So after /8, we have /9, the first classless mask. It's going to, the pattern, the interesting octet dot decimal notation number pattern is going to start with 128, then it's go to 192, 224, 240, 248, 252, 254, 255. There is a mathematical pattern here. So let's see. So there's 128, then you add 64 to 92, you add 32, that becomes 224, you add 16, that becomes 240, and then so forth. Actually, it's adding the magic number. You can tell the magic, you can see the magic number here. They also correlate in patterns to the CIDR masks. So the first classless mask is going to have a magic number 128. Then next is going to be 64, 32, 16, 8, 4, 2, and 1. 1 would be the classful masks. Do want to pause here a moment. Does everything I'm saying make sense so far? If someone could please quickly send a chat, just a yes or no. Does that make sense so far? Excellent. Thank you, Kate. Okay. So I'm glad that's making sense. Thank you, Jin. Okay. So yeah, it is important to memorize the patterns here. Now there is also the binary method, but that's really hard to figure out. You need a lot of practice. The magic number method, when you do this memorization, you can do this subnetting process really quickly, and it's much easier to memorize. That's why I stress the magic number method. Also, the textbook, the volume 1 textbook you have, also has chapters on subnetting that I do recommend reviewing if you're still struggling. They probably discuss it clearer than I do, maybe, but yeah, I definitely recommend reviewing the subnetting mod or textbook chapters if you're having trouble with this process still. But anyway, after we calculate the subnet mask into dot decimal notation, we then use this mask to find the normal and interesting octets. So if an octet in the subnet mask is 255, we copy the number in that octet of the IP address over to the subnet ID. For example, if we have 192.168.1.100 or something, because these first three octets have 255, therefore we carry over, or the subnet ID is also going to have the same three octets as the IP address we're given. So in other words, 192.168.1 will be carried over. So if an octet in the subnet mask is a 0, we also put a 0 in that portion of the subnet ID. And then finally, if an octet is either 255 or 0, it is the interesting octet we need to solve for that number. So in other words, in our example we were giving, or invisible example, it's 192.168.1, and then we have the interesting octet that correlates to this fourth octet in the dot decimal notation. Um, that 100 is not going to carry over. That's going to be a number we're going to have to solve for. So the next step is to find the magic number. It is found by subtracting the number in the subnet mask's interesting octet from 256, and this is another reason why to memorize these. So in our case here, for an example, we're going to have a consistent example in the next slide. But so for example, if your dot decimal notation is 252, or interesting octet, and the subnet mask is 252, you subtract it from 256, and you get the magic number of 4. So the next step is to find the multiple of the magic number that is closest to the interesting octet and IP address without exceeding that value. Note that this number cannot be larger than the number in the interesting octet. So it has to be the number or a multiple of the magic number, like going 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. It's doing that process and finding the multiple of the magic number that is closest to or equal to the interesting octet in the IP address without exceeding its value. We'll demonstrate that in the next slide. But finally, once you find that number, you just place it in the interesting octet, the subnet ID, and boom, subnet ID. That's what you get the subnet ID. So I have the process all written out right here. So we have a problem. We need to find the subnet ID, subnet address or subnet ID for 172.16.19.100/21. So I include the slash here because subnet ID is sometimes called subnet address in these questions. So if just to avoid confusion, subnet address is the same thing as subnet ID. Subnet address might appear in the questions in your quizzes and exams. But anyway, first step is to examine the CIDR mask and convert it to dotted decimal notation. So our mask here is /21. We take 21 divided by 8, and we have 2. So therefore, there's going to be two 255s in the subnet ID. The interesting octet of /21, if we go over to the table, if you have this memorized, it's going to be, fifth one, I think it's 248 if I'm correct. Yep. So 248 is the fifth classless mask. It was 248. So we write that down here. Do want to stress again, writing down these numbers on a piece of paper just over and over again. Write them down on a piece of paper, and you can memorize how to figure this interesting number. You can memorize this number, which mask it correlates to, by just writing it down. Write down 128, 192, 224, 240, 248. Write them down on pieces of paper over and over and over again. That's one way I memorized this. And then you can figure out which mask it belongs to by taking the counting from the first classical mask, or the classical mask that this mask associates with, and just going 1, 2, 3, 4, 5, which is /21, and that correlates to the fifth interesting octet number for dot decimal notation, which is 248. And that becomes that for our question here. And then the last octet is going to be a 0. So our subnet mask dot decimal notation is 255, the 255, the 248.0. Now we use the dot decimal notation subnet mask to find the normal and interesting octets. I made a little table here. So wrote down the IP address, wrote down the subnet mask. Now note how when there's a 255, we just carry over that number from the IP address over to our subnet mask, or subnet ID, excuse me. And you can write this down on a piece of paper. Write down the IP address you're given, write down the subnet mask you calculated, and then under it, write down your subnet ID. It's just, you're going to write down what you know about it. So we know when there's a 255 in an octet, That number in the IP address carries over to the subnet ID. When there's a 0 in the subnet mask, that is also 0 in the subnet ID. Finally, the interesting octet is a number we don't know. You can just write a question mark or leave it blank. We're going to have to solve for that number. So this is why it's good to use the subnet or magic number method. We only have to do minimal math. You don't have to do the big binary math. You only need to do simple math and memorize patterns to figure out the one octet you have to calculate. So finally, we find the magic number. We just subtract the number in the subnet mask interesting octet from 256, and we get the number 8. So 256 minus 254 or 248 is 8. Next, we find the multiple of the magic number that is closest to the interesting octet in the IP address without exceeding that value. So we got 8 times 1 is 8. That's going to be too low. So 8 times 2 is 16. That's pretty close to 19. So no, I want to stress here, we're finding the multiple of 8 that is closer to or equal to the 19. That's the interesting octet in the IP address. Now, if we go 8 times 3 is 24, that exceeds this number, so it's wrong. Because the subnet ID is always going to be before or less than the IP address. It's going to have a lower numerical value. So therefore, 8 times 1, or 8 is too small. 24 is too big because it exceeds 19. Therefore, 16 is our interesting octet. And then we just throw it in, that interesting octet right there, and we got our subnet ID. 172, that's 16, that's 16.0. Let me ask you all, does that make sense? Does this process make sense to you all? Thank you, Kate. Yes, I'm glad it does. So it may seem like a lot, it may seem convoluted, but trust me, it's a lot easier than binary. Once you memorize the patterns, it really, really makes this process go really quickly, which can really help with your exam times. I will say that memorizing this process, just writing down these numbers in this table here, are going to be crucial to getting good at this. So just write down the decimal notations, the magic numbers. You can even write down the masks they go with, and that will help you figure out this subnet ID stuff really easily. So broadcast addresses. I'll glance over some of this stuff because it's repeated for the most part. But basically, what you do is you again find the decimal notation version of the subnet mask. Most of the rules for the table here, they apply. Like when there's 255 in the subnet mask, that number from the IP address is carried over to the subnet or the broadcast address. When there's a 0, this is different. You put a 255, and then every non-0 or non-255 number is an interesting octet we have to solve for. But this is the difference with the broadcast address. You have to put 255 at the end of it if there is a 0. Or you have to put 255s in the broadcast address if there are zeros in any of the octets of the subnet mask, excuse me. So again, we find the magic number. We solve for the subnet ID again by finding the multiple of the magic number that is closest to or equal to the interesting octet without exceeding that value. And then finally, we take the multiple. The difference here is we take this multiple of the magic number, add the magic number itself to it, and then subtract 1 from it. So in other words, if our magic number, or if our decimal notation, or excuse me, let me try this again. If our interesting octet number for the subnet ID is 32, and our magic number is 4, we would add 4 to 32 and subtract 1 to get 35. And this number will be placed in the interesting octet of the broadcast address. So I'll demonstrate all this here. So we're going to take the same number we solved for in this slide, and we already found its decimal mask. Now here's the difference. When you have a 0 in the subnet mask, 255 is placed in the broadcast address. Note the difference here. So here in the subnet ID, 0 is carried a 0 in an octet of the subnet mask becomes a 0 in the subnet ID. A 0 in the subnet mask becomes 255 in the broadcast address. The interesting octet rules still apply. We find the magic number by taking this interesting octet number from the dot decimal notation mask, get the magic number, we find the multiple of it that either equals or is less than um, the interesting octet number in the IP address without exceeding that number. Then we take that number, which is 16 in our case, add the magic number to it, subtract 1 from it, and then we get our answer, our interesting octet. And we throw that into the interesting octet of the broadcast address, and we've solved it. So the subnet ID for this address is 172.16.16.0. Its broadcast address is 172.16.23.255. So that's how you solve for broadcast addresses and subnet IDs. Now, you may actually just get questions where you need to convert a CIDR mask to dot decimal notation. So if you're just given like /19, for example, you can either divide this number by 8, or memorize the subnet's class to determine the number of 255s. So a class A mask is between /8 and /15, inclusively between /8 and /15. It's only going to have one 255 in the mask, or only one octet is going to be 255. If you have a class B mask, which is inclusively between 6/16 and /23, you're going to have two 255s. Finally, if you have a class C mask, which is between /24 and /30, you're going to have three 255s. Next, you determine the number that belongs in an interesting octet. This octet comes right after the last 255, and you will likely need to memorize that number. It just helps to just memorize which ones. So we have /19, for example. Now we know we know this is a class B mask, and the classful mask in class B is 16. So we count 17, 18, 19. And the interesting octet dot decimal notation, numbers that correlate with that. So we can count like 128, 192, 224. So you can actually on paper write this down. Write down the first classless mask that comes after, like /16, for example. It's going to be /17. Memorize the dot decimal notation that comes with it, or that is associated with it, which is 128. And then keep going until you reach the mask that you're solving for. And then you should have the interesting octet number that goes with it. Put in the interesting octet. And then you place zeros in the last octets that are not 255 or the interesting octet. So notice the pattern with the interesting octet numbers and the classless CIDR masks. So yeah, I already went over all this. So yeah, if you just pay attention to what the slide is saying and memorize these patterns, calculating these masks becomes very easy. Wildcard masks. I don't know if you're gonna have any questions on it, but just in case, all you need to do to calculate a wildcard mask is take these. I'm real sorry. I'm real tired this morning. So basically, what you do is you write 255s, all 255s on top. Then you write your subnet mask in dot decimal notation on the bottom, and then you subtract. So 255 minus 255 is going to be 0. Your interesting octet is going to be subtracted from 255 and be placed here, and then 255 is going to be placed wherever there's a 0. So yeah, wildcard mask calculations are pretty easy once you memorize the subtraction process. No, VLSM. I don't know what kind of VLSM problems are going to be in your exam. I'm quite honest. These are slides from last semester with the questions we had. These questions appear in the practice question or practice quizzes right here. No credit practice calculating masks. I don't know if these problems will appear. There's a chance they will. Just in case they do. Oh, I'm sorry. No, I'm talking about this. Okay, my apologies. So we used to have VLSM quiz questions when we had this class, when I was a student and when I was a TA last year. I haven't seen any quiz questions that look like this in your Canvas shell. But just in case there are, I would start memorizing this process now. It's not that hard, but for example, you may have a question where you're given a mask and then a classful address space, and you need to find the next lowest possible subnet numbers there are in this mask. So the way we do this is we write down the next three lowest subnets by first finding the magic number from the subnet. Magic numbers are in a pattern from 128, 64, 32, and so forth to 1. So this pattern starts on the first mask that follows a classful mask. So for example, classless mask is going to be /9 coming after /8. So /9 is going to have 128, /10 is going to have 64, and so forth. So /20 here has a magic number of 16. So we know class 20 or /20 is a class C no, excuse me, class B or cider mask. So /16, we're going to start counting from there. So /27, excuse me, /17 is 128, /18 is 64, /19 is 32, and then finally /20 is 16. So use the magic number to write down the next subnets by placing the multiple of the magic number in the interesting octet. So that's going to determine on the class of this mask. So I would recommend writing down these ranges /8 to /15, /16 to /23. They tell you what class these masks are in. So if it is a class A address, the interesting octet is going to be the second octet. For the class B address, the third octet is going to be interesting, and then /C, the fourth one is going to be interesting. So /20 comes between /16 and /23. Therefore, it's class B, and the third octet is going to be interesting. So therefore, we just take the magic number, which is 16, and write multiples of it. So 16, 32, 48. So just need to memorize your basic multiplication factors, and you'll be able to do this pretty quickly. It's not that hard. You can actually write down your own practice questions for this. I do also provide a second question for y'all's practice later on. So let me ask you, did any of you have any questions about this process? Does it seem pretty easy? Kind of. Okay. Sort of. Is there anything I can explain better? You can just type in the chat if there's anything I can explain a little better. Is there anything that's confusing you here? Okay, I'll assume to move on. But maybe I'll just go ahead and go over this again. So we're given a mask /27, and we're given a classful address space. We need to find the next subnet, lowest subnet number. So basically, we're finding the next three subnet IDs. It's a pattern. So /27. So basically, we start by using the mask to find the magic number. This is paternal memorization. So if we're going over here in this table is really good to memorize. We write down the cider masks and the magic numbers that go with them. If you write this down multiple times every day, you should be able to memorize it pretty quickly. So /27 is what we're looking for. So we can find the class that this mask is in. It's class C. So the first classful mask is /24. Remember the classful mask are /8, /16, /24. Memorize those, see the cider mask you're given, and see which class it's in. It's going to be greater than the one mask. It's going to be less than the next mask above that, or the next classful mask above it. So /27 is greater than 8, it's greater than 16, it's greater than 24. Therefore, it is in class C address or mask. So we count from 20, or starting from 24, we go up to 25. We write down the first magic number. It's going to be 128. Next one is 20 or slash 26 is going to be 64. Finally, slash 27, what we're solving for, the magic number is 32. So we determine what the class the mask is in, which one is the interesting octet. So slash 27 is a class C address. It comes after slash 24. Therefore, the fourth octet is interesting, or the interesting one. Therefore, our next mask or subnet, we just add the magic number to the interesting octet of this classful address space. So it's 172.16.0 that or dot 16. And let me check there. Is it 32? Let me see that. I'm sorry, 32. Okay. 172.16.0.32. And then you add 32 again to 16. Your next one's going to be 172.16.0.64. And then 172.16.0. Okay, 32, 64, 96. So when you memorize that pattern, that becomes easy. Now, granted, these may not be in the exam at all. You may have something different for VLSM, but I would say this process is probably going to come closest to something you might see in the exam. This is what we had last semester and the semester before that, and then when I took this class, the semester before that one. Dr. Assad has not given me the exam questions. I don't know what subnet or VLSM questions he's going to use, but it's a good chance it's going to be something like this or something similar. So that's a practice to memorize. Now, you may also be given a list of subnets, and you may need to add a new subnet based on the mask you're given. So this process may seem daunting at first, but it's all about writing or avoiding overlap. And the way we do that is we write down these, we're given the subnet IDs of all these networks. We just need to solve for the broadcast address. When you do that, you have the ranges of these subnets. So you figure out how many subnets, or excuse me, how many addresses these subnets are taking up and what the next available subnet ID is. So for example, 172.16.0.0 to 172.16.3.255, the next available subnet ID would be 172.16.4.0. So basically, it's just by finding the magic number, adding it to the 0 here, or whatever number is here to the interesting octet, and then a 0 at the end. Or in other words, it's going to be +1 of this, and then a 0 at the last 255, or whatever 255s are there in your mask. So when you figure out the ranges of these subnets, you take the mask you're given in the classful address space, and you find a subnet that will fit in between here without overlapping, the lowest one without overlapping. So we're given /20. I can tell you its magic number is 16. We solve for the broadcast address, and we find that 172.16.0.0's broadcast address is not 15.255. If we add 16, or if we add +1 to here, or in other words, if we look at the next address after this broadcast address, it's 172.16.16.0. So this will help. Figuring out the ranges of these will help us determine how many addresses these subnets encompass. This range is encompassed by the interesting octet. It is 16, so we need to find a place in the given list where this subnet can begin with a multiple 16 in the interesting octet and not overlap with another subnet. So if we look here, our next available subnet following this, because .0.0 has already been taken. So what about 172.16.16.0? Well, we can see here that's already taken here too. So the next available subnet, 16 plus 16 is 32. We know from finding that broadcast address, it is 47.255, if I'm correct. And the next available subnet the next listed subnet is 64. So this mask does work. There's no overlaps. So you can see that whole process here in red. I want to ask you all in the chat, does this make sense? I know this may seem a little confusing at first, but it's similar to the other subnetting or VLSM question where you just use the subnet ID and you figure out the range of these masks. Let me ask you all, does this make sense? Can I explain more? Yes. What do you want me to explain? Can you specify something you need me to explain? If you don't know what to specify, just please, you could just please put I don't know. I just need to know if there's something you need me to explain more in detail specifically. If there's not, I'll go over the process again. I'll try to be clear. Okay, thank you. That helps. Okay, so let's go over this again. There may be questions I don't know for sure because this is what we did last semester. I don't know what Dr. Assad's going to do. He's not revealed the quiz questions or exam questions to me. But there may be questions in the exam where you're given a list of subnets. You're tasked with taking a mask and this classful address space and then finding the lowest possible subnet number you can put in this range that does not overlap with any subnets. Is that clear so far? I'm going to go step by step and ask if you understand what I'm saying so far, and then if you don't know what I'm talking about, I will explain. So does that part make sense so far? Thank you. Excellent. So, well, how we begin this is taking the classful address space we're given. We take the subnet mask, and then we find the broadcast of this subnet. So we're starting from .0.0. Take the subnet mask, find the magic number, go through this process right here. Go through all this stuff, and then we find the broadcast address. So we know the decimal notation for this, or we can figure that out. 20 divided by 8 is 2. So there's going to be 255s, or two 255s. Interesting octet is going to be, let's see, 128, 192, 224, 240. I'm correct, 240. And then we have 0 at the end. So these two numbers are going to carry over because they overlap with 255s. Interesting octet is going to be the third octet, and then the last number is going to be 255. It's going to be, since that number in the decimal notation is 0, this will be 255 in the broadcast address. The magic number is /20 because it's 240. So 256 minus 240 equals 16. So 0 is the interesting octet so far in the address we're given. Therefore, it is just 0. Our interesting octet is 0. 16 times 0 is 0. To find the broadcast address, we add the magic number to this interesting octet number, which is 16. We subtract from 1, we have 15. So that's how we determine the broadcast address. This is significant because this is the range of the subnet. In other words, all the IP addresses that are used in the subnet are between these numbers. So like 172.16.0.1.2.3.4.5 up to .15.254. Those are all usable addresses that hosts in the subnet can use. This number determines the last number in the subnet. Does this make sense so far? Excellent, thank you. So now that we have the broadcast address, what we can do is, let's see, let me start that over. So let me read this here. So by doing this, it helps us determine the range of addresses this subnet encompasses. Note that this number range note the number range that is encompassed by the interesting octet. It is 16. So in other words, 0 plus, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So counting from 1, we're starting with 0, and it goes all the way up to 15. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 16 numbers there. So, and this would also carry over to the next subnet with this mask. So how you figure out the next available subnet ID is you basically take the magic number, you add it to the interesting octet, and you basically get in our example, 172.16.16.0. So at the bottom here, this is demonstrated. So I have the first subnet, 15.285 for the broadcast address. So the next available subnet ID is the magic number plus the interesting octet, which is 0 plus 16 equals 16. I do that again with 0 plus 6, or 16 plus 16 equals 32. So that's how you can figure out these subnet IDs. And then with those subnet IDs, you can figure out the broadcast address. It's going to be a mathematical pattern with the magic number. So basically, we need to find a subnet doing this process, finding the subnet IDs. Whoops, do that there. Whoopsie. Okay, you just write out these subnet IDs. You determine the broadcast addresses, and you see if these subnet ranges right here overlap between these. So 0 to 16, or so we can see so far the first subnet mask, or the first subnet. It starts with 172.16.0.0. The first subnet we figured out was 172.16.0.0. They shared the same subnet IDs. This would not work because it would overlap with this whole subnet. The next available subnet, or listed subnet right here, is .12.192.16.12.285. This also overlaps with this subnet also overlaps with this one. It comes between, so notice that .12 comes between .0 and .15 in the third octet. This range is inside this much bigger subnet. This is a much smaller subnet, but it is inside the addresses that are encompassed by this entire subnet. So therefore, this also further proves we can't use this subnet ID. Then we try the next subnet ID. We add 0 plus 16, which is the magic number, equals 172.16.16.0. We'll find the broadcast addresses, 31.255. We see if any of the subnet masks or subnets in this list are would overlap with this subnet or are exactly the same, which is the case here. This exact subnet is already used in this list, so we can't use this. We can't use this as our answer. Therefore, we take the magic number again, 16 plus 16 equals 32, and then we find the broadcast address, .47.285. So we see here the 172.16.32.0 subnet ID is not taken in this list. Also, we see the next subnet ID is .64, which is less than 47. Therefore, this range is the lowest one that will work in this network and is the one that will be our answer. So your answer would basically be 172.16.32.0. You just put down the subnet ID. Let me chat again. So chat, does this make better sense now? Thank you, Jen. Yes, thank you, Kate. I'm really glad that makes a lot more sense. I'm sorry about the way I initially was talking about it. I guess it was rather rambly. I'm sorry about that. Again, what's sad is that I don't really know if these are going to be in the exam. I really don't. I wish I did, but there is a chance that Dr. Assad may pull from the previous questions from the previous iteration of this class along with mine, because mine in this exam too did not include VLSM. So as a heads up, you might want to practice this stuff. All it really is solving for the broadcast, or it's solving for subnet IDs. Both of these processes involve just using the magic number and solving for subnet IDs. And in the case of these, where you got a list of subnets, just find the broadcast address for each of these subnets and keep doing that. Keep finding subnet IDs and broadcast addresses and make sure there's no overlap. The lowest subnet you find that doesn't overlap will be your answer. You just take the subnet ID. Let me actually write that down. 16. So yeah, there. That's for greater clarification. So when you're all studying this, I put that there just to clarify. Okay. We're not done with subnetting yet. We got selecting subnet mask to maximize subnet/hosts. That may sound confusing at first, but I'll explain it here. This all might be confusing, so um, basically just know this. Um, when you're going to be given questions that look like this, possibly in the exam, there may be questions like this, and these questions right here correlate to, go back up here, this practice quiz, calculating mass. Unfortunately, I don't believe there's any VLSM quizzes in the Canvas so far. I don't know, but if there are, I would say take advantage of them. So calculating masks, that no credit practice quiz is going to correlate with these questions here. So you're going to be given a subnet or a subnet ID, the number of hosts needed, and the number of subnets needed, and you're just going to, or number of hosts and a number of subnets, not necessarily necessary. Sorry, not necessarily needed, but what mask would maximize the number of subnets? And then you're going to write your answer in CIDR format or CIDR format. So if you're asked to maximize subnets, you'll follow this process here. If you're asked to maximize hosts, you'll follow this different process here. So there's two different processes. So just pay attention to the wording of the question. Now, if you're asked to maximize hosts, basically what you need to do is finding the minimum number of, or excuse me, if you're maximizing the number of subnets in a network, finding a mask that with this subnet will maximize the number of subnets you receive. In other words, the number of networks given with this classful address. You'll need to find the minimum number of hosts based on the number given here. To do this, you will find a specific. You need to find a specific value, the host bits. So we're working with we're working at the bit level, but we're using some mathematical shortcuts to keep you from working with binary. Honestly, I don't even think this process was ever taught in binary. I don't remember. But anyway, this simple math method is a lot better. So basically, when you see maximize number of subnets, you need to find the host bits. So subnets, host bits. Maximum subnets, number or needed host bits. Maximum hosts, needed subnet bits. Just memorize that. That's going to be key in doing well in these problems. To define this value, or in our case, for this example, the number of host bits, we would use this formula. So needed host bits is greater or less than or equal to 2 to the power of h minus 2, where h is host bits. So with this form, so in other words, the answer we're going to receive is not going to equal 6. It's likely going to be a little bigger than 6. It might equal it, it may not. Well, we'll see. So with this formula, we'll find the closest number that matches or exceeds the number of needed host bits, which is 6 in this question. So 6 is greater than or less than or equal to the power of 2, or excuse me, 2 to the power of h minus 2. So you're finding a power of 2. And so 2 to the power of 1 is 2, minus 2 equals 0. 2 to the power of 1, or you have 2 to the 0. Okay, 2 to the power of 2 equals 4, minus 2 equals 2. 2 to the power of 3 is 8, minus 2 equals 8. Or 2 to the power of 3 equals, let me see here, 8. So 8 minus 2 equals 6, because you have to follow this formula. So 6 does equal the number of hosts bits. So therefore, your power of 2 in this case is your answer is 3. Do I need to clarify this a little bit? It does sound like I'm maybe making it a little confusing. Are you understanding what I'm saying so far? I know this is probably sounding a little convoluted here, but just bear with me a little bit. If you need me to explain this again, I will. Okay, I'll assume yes. So let's start over with the math. So if you are asked to provide the maximum number of subnets, you need to find the necessary number of host bits. So basically, you're finding the minimum number of host bits. You're basically allocated number of bits in your subnet. So if you're thinking the binary level, we're finding the least number of host bits so we can have the maximum number of subnet bits. So we're increasing the number of subnets we can have with our network based on the mask we give this subnet. So there is binary. The process behind this is binary, but we're using math as a shortcut. So the mask that would maximize the number of subnet bits or maximize the number of subnets, we find that by finding the needed host bits, or the number of host bits that will meet or exceed the number of hosts required. So let's see. So that is why 6 is less than or equal to. So our answer on this side is probably going to be greater than 6. So that's why this sign is here. It could also be equal to it, but we need to find a power of 2. So we're doing exponents here. This exponent we use is going to be used down here in our calculation. Not this equals number, this h, this variable. It is a power of 2. That is going to be the number we use in our calculation for the mask. So 2 to the power of 1 equals 2 minus 2 is 0, so that's not going to work. It's not going to give us any host bits. If we try 2 to the power of 2, that's 4 minus 2. That's less than 6, or 2 minus 2, or 4 minus 2 is 2 hosts, and that's less than 6 hosts, the needed 6 hosts. 2 to the power of 3 equals 8. 8 minus 2 equals 6 hosts, and therefore our exponent, 3, is going to be our answer for this step. Once you find this exponent, you just subtract this exponent from 32, and you get 29. Therefore, in this case, slash 29 is the answer, is the mask we need for this subnet to maximize the number of subnets but meet the required host bits. So you will need to also answer this in CIT notation. You need to include the slash. So let me ask you, chat, just answer yes or no. Does that make sense? Thank you, Kate. Okay, good. So that isn't terribly hard. If you know what you're doing, it's not terribly hard. And you do have this practice questions. I keep bringing it up, but yes, there's practice questions for this process. It's a little difficult at first, but once you memorize how to do it, it's pretty easy. So there are other questions that can ask you to maximize hosts. So we need to find the mask that provides the number of bits necessary to support the needed number of hosts or subnets, which is 15. So again, it's a power of 2, but we don't subtract from 2. The reason we subtract from 2 in this question is because in a subnet, the subnet ID and broadcast address cannot be allocated to a host. Therefore, we have to subtract those from our calculation. So anyway, the number of subnet bits, or the exponent in this case, will be our answer again. So we need to find an exponent, or power of 2, that equals or is greater than this number here, the minimum number of subnets needed. So 2 to the power of 3, remember, is 8. So that doesn't matter. That's less than 5. It's not going to help us. 2 to the power of 4 is 16, which is greater than 15. Therefore, our answer is 4. That's the exponent we used. Now, the process we use here is a little more difficult. So we need to add the number of network bits plus subnet bits to get the mask we're getting, or to get the mask for our answer. The number of network bits is determined based on the class of this IP address. So I'm probably gonna have to include those somewhere, but so basically there's a number of there are IP address ranges from .1. There's one. The first octet is 1 to 127. That's the class A, and the number of network bits is going to be 8. There's 128 to 191, I believe. That is class B, and that's the network bits is going to be 16. And then finally, class C is 192, I believe, or 191 to something, and that is going to be 24. Network bits is going to be 24. I'll write that down later in this. Don't worry. But anyway, So 24, this is a Class C address. The number of network bits is 24. Therefore, 24 plus 4, which is our exponent, equals 28, and that is our mask. So I'll add that information to this slide later for figuring out the IP address ranges and the class they're in and the number of network bits they all have. I'll add that table or add that information after this session. Um, ooh, it's not the right title. Okay, powers of 2. So if you need help memorizing the powers of 2, I recommend taking this table and similar to all this other stuff here in this table, write it down. Write it down over and over and over again until you memorize these by heart. Once you can do that, you should be able to do these problems a lot easier. So that's enough subnetting. Yeah, subnetting took up the vast majority of this study session. I don't know how many subnetting questions you're going to have in the exam. There could be quite a few, could be an equal amount compared to the other topics, but just be prepared to do a lot of subnetting. Subnetting could probably take up a lot of the exam, just to let you know. So that's why I provided all that content and stuff, because you really need to know a lot of it. It's a lot to know, and I'm hoping some of you are practicing it. I'm hoping you all were practicing it from the time you learned it, because you will be tested on it and no calculators are allowed. So hopefully scrap paper will be allowed and you can write down the stuff that you solved there it. But anyway, we'll now turn our attention to some basic router facts. So some of this information could be in the exam, just to let you know. So routers are layer 3 network devices that allow clients such as computers and printers to communicate with other client devices in different broadcast domains or subnets or LANs. These three terms are very similar to one another. Broadcast domain, LAN, pretty much synonymous. Subnet refers to the IP addresses or refers to the IP addressing of these LANs and broadcast domains. Each port on a router is in its own broadcast domain and therefore has its own subnet. You've probably learned that from your router labs in GNS. So routers use most of the CLI commands you've been using with switches, but have ones not seen on switches such as show IP route. That is for the routing table. Switches don't have that. Speaking of routing tables, they list the routes to different subnets. The router will use the subnet mask and subnet ID in a route when matching a packet's destination address. Look, these are boldface. This is something you're probably going to be tested on. Just to let you know, this is probably going to be very important for the exam. This key here, the router will use the subnet mask and subnet ID in a route when matching a packet's destination address. Remember those two, and also remember this command here. Sources of routes. Don't stress out too much about this table. I don't think you're going to need to know the commands just in case they're here. What you need to focus on is how these routes are created. So connected routes are created when two adjacent router interfaces are enabled with the no shutdown command and have IP addresses configured. So, for example, connected route is automatically created when you are on a router, you select an interface, you add its IP address and subnet mask, and do the no shutdown or no shut command. Static routes are manually configured by network administrators. They require extensive planning for larger networks. They're not very scalable because they're very complex and they're not able to adapt automatically to network changes. Basically, you just need to know how to create one. It's the same process we've done all semester. It's subnet ID, destination subnet ID, the subnet mask, and the destination subnet, and finally the adjacent or the IP address of the adjacent interface to the router you're configuring. So this is the interface on the other router that the router you're configuring is connected to that leads to this subnet, or the router that leads to this subnet. Its IP address right here is going to be included in your command on the router you're configuring. Let me explain this again. So when you configure a static route, this address here is going to be on the other router you're not configuring. It's going to be the one that's connected to the router you're configuring, and that router is going to lead to this subnet or this destination subnet. Does that make sense? Chat, could you say yes or no and make sure that makes sense? Thank you, Jen. Excellent. So also you can just use the interface on the router you're configuring that leads to this subnet, to the router that is connected to the router that leads to this subnet. Either one is perfectly valid. Now, there are default static routes. These are a type of static route that matches all destination addresses. There are 3 unique route types. This is not one of them. This is a subset of static routes, just to let you know. That is provided just for completeness. I'm going to mark it a different color to clarify that. So it is a different kind of route, or it's a specific kind of or it is a specific type of static route. The reason I include it is because you just need to know how to configure it, or why it's used. It is used when no route in a routing table matches the destination IP address of an incoming packet. It's listed with the asterisk sign in a routing table, and you just configure it by putting 2 rounds of 4 octets of zeros, and then the IP address of the router that is connected to the router you're configuring. Yeah, it's just the IP address of the router that is connected to the router you're configuring. So finally, routing protocols. So these are automatically created. These routes are automatically created after the administrator configures routing protocols such as OSPF, RIP-v2, and EIGRP. Prefixes will vary by routing protocol. So for example, like when you see an OSPF route, you see an O instead of a C or an S. And OSPF is used in this class. Let's remove that. We've already learned that stuff. Okay. There we go. So conf T, router OSPF1. So this is how you configure OSPF. You go into Google configuration mode. You go OSPF1. So you have the subnet ID, you have the wildcard mask that goes with it, you just put area 1, and then you create your passive interface. Speaking of OSPF, we'll provide some facts on it that you could be tested on. So OSPF is a widely used routing protocol that helps routers automatically learn each other's routes. The following are some facts concerning the protocol. Unlike other routing protocols, OSPF uses link state logic. That's going to be important. Link state logic as a metric to choose the best/fastest path available to a specific subnet. Like EIGRP, OSPF's metric is at least partially affected by bandwidth. Now, other routing protocols are included here. You might be tested on them as well. You might include a question on routing protocols in general. Pay attention to what I include here in these lines. They're going to be most likely be your answers to your questions. Along with RIP-v2 and EIGRP, OSPF is compatible with VLSM. RIP-v1 is not. So yeah, that's important. Whoops, my apologies. RIP-v1 is not VLSM compatible, just to let you know. OSPF allows routers to inform one another about available routes through link state advertisements or LSAs, which advertise the routes created from the network commands. Like back here, this network command, this is basically creating an OSPF advertisement. OSPF utilizes a concept known as areas, which divide networks into a set of routers that share LSAs in order to reduce bandwidth consumption from OSPF processes. Single area OSPF is used in this class. You won't get into multi-area OSPF unless you take CIT 447. But anyway, OSPF allows for further bandwidth savings through the use of passive interfaces, which prevent certain interfaces from sending or processing OSPF hello messages. Router interfaces with PCs connected should be made passive. So that is important here. Router interfaces with PCs connected to them should be made passive. With PCs connected or no routers connected should be passive. So basically that's typically just going to be with the PC. So I don't know if you'd be testing on that fact, but I just included it just in case. Okay, final slide, just the OSPF commands. So you just go configuration mode, router OSPF1, write down the command network, put the subnet ID, the wildcard mask, which I provide steps on calculating that right somewhere here, right here. I could provide instructions on how to calculate wildcard masks right here. Then you put the area and then just put 1, just area 1. Then passive interface, you write down the interface name that you're making passive. So these are some examples of network commands. So just a subnet, wildcard mask, and area 1. If you want to check your OSPF configurations, you can do show IP protocol. Shows your OSPF configurations, including the routes and passive interfaces you configured on that router. Then the IP route show IP route command shows the OSPF routes that the router learned from other routes. So when you type this command, this is not going to appear in your routing table. What you type in other routers that the router you configured learned, that is what's going to appear in show IP route. Okay. That concludes this study session. I know it was pretty lengthy, but there was a lot to go over for subnetting. I wanted to make sure you had everything you all needed for subnetting. I hope you've all find it helpful, and I wish you the best of luck on the exam. I'm sure if you put a lot of practice into subnetting, you should do just fine. But anyway, I want to ask you too, since you're here, if you want to speak or chat, either one. Um, has this study session been helpful overall? Do you feel like you're much more prepared for the exam, or considerably? Excellent. Thank you, Kate. Thank you, Jen. So don't worry about having to come back to this video if you want to look at the PowerPoint again. I will post the PowerPoint on Canvas. I'm going to try to include that information I need to add to it. And that should be all. Unless you got questions. Honestly, now is going to be question time. If you could just type yes or no if you got questions in the chat. If you do have questions, I'll keep recording. If you don't, I'll stop. Okay. Jen, you have a question? Excellent. Okay. Thank you all for watching. I hope you all have a good day.